Hey everybody, this is a video to show the relationship between current, voltage, and resistance in an electrical circuit, otherwise known as Ohm's law. Okay, so current is the first variable I'm going to talk about today. So current is the flow of free electrons through a conductor. The symbol for current is the letter I. The unit of measurement is the ampere, or as we say in the field, amps. The second component of Ohm's law is voltage. Voltage is the pressure or potential that pushes the free electrons through the conductor. The symbol for voltage would be the letter E or V, depending on where you're talking or what voltage you're talking about in the circuit. E is typically used for the supply, and V is usually used across the load. So the unit of measurement for voltage is volts. The next variable I'm talking about in Ohm's law would be the value or variable of resistance. So the symbol for resistance is the letter R, and the unit of measurement is ohms, and the symbol is the omega. So the formula for Ohm's law is I, current, equals E, voltage, divided by R, resistance. So if you were to keep resistance constant in an electric circuit and you changed voltage, current would change proportionally, meaning that current and voltage are directly proportional. So in direct proportion, if again resistance being constant, if voltage were to go up, current would also go up the same amount. It is also true to say that if voltage is constant, unchanging, and if I were to change the value of resistance, current would change indirectly. So it would be known as indirectly proportionate. So if R were to go down, current would go up. So in this case here, we have direct proportion. And in this case here, we have indirect proportion. Okay, so now I'm going to mathematically prove that current and voltage are directly proportional when resistance is constant, and that current and voltage are indirectly proportional to resistance. Okay, so let's start with an electrical circuit. Okay, so here's my 2 points of potential, my voltage, resistor. Okay, so I'm going to go with 24 volt supply and a resistance of 4 ohms. Okay, so I'm going to apply Ohm's law, I equals E over R, to the circuit and see what my current's going to be. So 24 volts divided by 4 ohms gives me 6 amps of current. Okay, so that's how we would apply Ohm's law to that specific circuit. So if I wanted to now prove direct proportion, that current and voltage are directly proportional, meaning they would increase at the same rate if resistance were held constant. So let's now double my voltage and see if that in fact causes my current to double. Okay, so here's my circuit. So now I'm doubling my voltage, 48 volts. Resistance stays at 4. Let's see what happens to my current. So I equals E over R. So now I have 48 volts divided by 4 ohms. That in fact doubles my current. So 12 amps. So we've mathematically proven that current and voltage are directly proportional when resistance is held constant. So now I want to prove the indirect proportion is true as well. So I'm going to go back to my 24 volt supply and then change my resistance and see what happens to my current. So E, or source voltage, 24 volts, and now my resistance is going to double. I am going to increase it by 4. So my resistance in the circuit now is 8 ohms. So let's apply that mathematically to my formula. I equals E over R. So 24 volts divided by 8 ohms gives me a current of 3 amps. So mathematically, when we had an increase in resistance, we saw our current decrease, proving indirect proportion. So using Ohm's law, we can solve for any unknown variable in an electrical circuit. Thank you.